We're recording. So the first thing says, if I take a pair of parallel lines, okay, watch this. I'm going to take these parallel lines and I'm going to go, I'm going to edit, file, edit, copy, file edit, paste. So what it says is that, well this, oh that doesn't really work. Let me see. Never mind. If these are the same, if I take two sets of parallel lines and they're exactly the same distance apart, and I were to take this set, let's see if I can do this. Take these and rotate them. Can I? Ooh, I can do it. Rotate them, and then I'm gonna move this thing. Let me do that. I want to select both of them, and I want to move them over here. Okay. What shape is this right in here? Rhombus. That's a rhombus. Very good. Okay. And that can be proven, and that's what conjecture C48 says. It says if two parallel lines are intersected by a second pair of parallel lines that are the same distance apart as the first pair, then the parallelogram formed is a rhombus. So this thing right here turns out to be a rhombus, and that could be shown. The proof of that would be fairly complicated, but so if you ever want to construct a rhombus, all you have to do, you can take like a ruler. Let me just pause a second.
I want to draw the sides.
Yeah.
Which one?
Let's move on. So C49, what does C49 say? C48, the diagonals of a rhombus are blank and they are blank. So if I do have a rhombus, and say did I start recording again? I'm recording again, okay? So the diagonals of a rhombus, if I were to draw in the diagonals in here, okay? Here's this one here, and here's this one here. What appears to be true about those diagonals, Jared?
They make right triangles.
Very good. They make right triangles, and what do you say if they? What are you going to say, Will?
I was going to say they're perpendicular.
Very good. They make right triangles and they're perpendicular. And something else is true about them. If they also cut each other in half. Okay? So on your conjecture sheet, you should put that it says C59 or C49. It should really say C49. Okay? See, the diagonals of a rhombus are perpendicular and they bisect each other. Okay? So you say they're perpendicular, and they bisect each other. Are you writing this down on your conjecture sheet? You should. I'm going to check your conjecture sheet during the test to give you a 10-point grade on it. Okay? Bisect
Make it like 5 points.
each other. Okay? Oh, now you need one. Now you need one. That's the one. C50 should say that the diagonals of a rhombus do bisect the angles. So because with these triangles all end up being congruent, these angles, this one and this one are congruent, and this one here and this one here are congruent. Maybe it'd be better to draw a bigger picture of a rhombus. All right? Kind of hard to draw a rhombus? Well, maybe not that hard. I'm going to try to draw a better rhombus. We can build a better rhombus. So here's a nice rhombus. And now we're talking about the diagonals of a rhombus. And we have learned that the diagonals of a rhombus are perpendicular. So all these things are perpendicular. This piece is congruent to that piece. This piece is congruent to this piece. and only in a rhombus, not in any parallelogram, this angle is congruent to this angle is congruent to this angle is congruent to that angle, and this is congruent to that. So that's only true for a rhombus. It's not true in a parallelogram. The diagonals bisect, but they don't intersect at a right angle, nor are these angles here congruent. Okay? And the reason that all those things are true is because it would be very easy to prove that triangle 1 is congruent to triangle 2, which is congruent to triangle 3, which is congruent to triangle 4. You could show that all 4 of those triangles are congruent in a rhombus, and then that's where all these properties come out of. Okay? The next thing we're going to explore some things about the diagonals of a rectangle. Diagonals of a rectangle are blank and blank. Let's try to draw a rectangle. Okay? Diagonals of a rectangle. I could get a rectangle right here. Can I not? Here's a rectangle. Rectangle. What do you think about the diagonals of a rectangle? Very good. Okay? Diagonals of a rectangle are congruent. And also, do they cut each other in half?
Yes.
Yes. They are congruent, and they also bisect each other. Okay? And bisect each other meaning this diagonal cuts this diagonal into 2 equal pieces. Okay? So for C51, you should have the words congruent, and you should probably have a picture with each of these, and bisect each other. And if we, what?
My paper doesn't fix it like
Your paper, what?
Like when I draw a rectangle, it doesn't fix it.
It doesn't. Maybe you could invent that technology.
Mine doesn't either.
Good, it's gotta be cool. Hey, the reason that that's true, just to show you guys, because these have to be right angles, right? And in a rectangle, this side is congruent to this side. So you could prove that this triangle here is congruent to this triangle here by side angle side. Therefore, these diagonals would have to be congruent. And you could prove that these triangles here are congruent, and therefore, anyway. Okay, last conjecture says something else about a rectangle. And, oh no, it says something about a square. So, a square is both a rectangle and a rhombus, right? So, in a square, which is both a rectangle and a rhombus. Where's a square? Square. Is this a square? Is this a square?
Yeah.
This looks like a square. I don't want a shaded square.
It's a red square.
Red square?
Dotted
Yeah,
square.
red square.
There we go.
Let's take the dotted square, but let's not make it dotted anymore. Let's make it solid. Now it should be a solid square. Wow!
Wow.
I'm getting good with this thing. Guys,
Bless you.
God bless you.
I felt that one.
So, diagonals of a square do all the things that both a parallelogram and both a rhombus and a rectangle do. So they're perpendicular, they bisect each other. What else do they do? Each other, and one more thing, and they're congruent. Congruence. Okay? So that's what you should have for C, what number is that, 52? C52? Is that one? Diagonals of the square are perpendicular, right? All those are right angles. They bisect each other, and they're equal in length. Okay, now you might have, I'm writing that down, just to show you, you are going to have a couple constructions in your homework. So one construction you might see is something like this. I'm going to go on to the next page. Construct a rhombus given diagonals AB, and CD. I should have made that capital. So, say you have two pieces. Here's AB, and here's CD over here. How can I construct a rhombus out of those two things? You want to see? Should I try to use my compass here?
Let's
What?
see it.
Okay. So first thing I'm going to do, I'm going to bisect this. I won't pretend, I'll actually take my compass. Where's my compass? Is it on here? Tools, compass, I can do this. Okay, so if I were going to construct first thing I want to do is bisect, make the perpendicular bisector of this side. So I'm going to take this, put it here, and I'm going to come over here to here, and move this. How many degrees is it? 68. I'm going to make sure it's 68 when I come over here. 68. Up. One more degree. 68. And now I'm going to drag this. What did I do wrong? I didn't go more than half. Okay, so I have to make it bigger over here. I messed up. And then I have to flip it over here. Okay. Now I'm at 87 degrees, so let's remember 87 degrees. There, it's still at 87 degrees. And I'm going to intersect this. Okay? It's kind of a mess, but now it works. And now I'm going to connect this point to this point using my straight edge. And I would go like this through that point and through that point. So now I've made the perpendicular bisector this. Okay? Now, if I take this segment and I cut it in half, I'm not going to do it right now, but if I cut that in half by doing the perpendicular bisector, and I take the distance from here to here, mark off that distance here, and mark off that distance here, then when I connect this to here, and this to here,
Whoa.
and this to here, and this to
No
here,
way.
that shape should be a rhombus. Okay? So basically, you find the perpendicular bisector of this, and then you find the perpendicular bisector of this, and then you measure off the length, half length off of here and half length there, and that should end up being a rhombus if you did it correctly. Okay? So anyway, your homework is homework.
Yo, don't be that guy. We
can
have
lead
leaders.
us.
Don't be that guy. The last piece of paper, Mr. Leader.
Last week, better get smart. Page 294. First ones are pretty straightforward, easy. 1 through 13. And then 14 through 24 evens. Okay? There you go. And that was kind of a bad. It's a lot of problems.